Kiitos. I'm happy to be here. Excited to talk once again about systems. I think this is probably a new topic for you today. You probably haven't heard this word today a lot. So there's going to be one more, or probably several more still today, talking about this topic. And so, yeah, thanks, Andre, for the introduction. And just briefly, so my name is Karri Saarinen. I'm from Finland. I grew up here, but about 5 years ago, I moved to San Francisco to start our own company, this bookmarking app, Kipt. And we ran that company for a couple of years, and then we joined the Bitcoin company, Coinbase. At Coinbase, I led the design there. I was the first designer, and then later on, the head of design. And the last 2 years now, I've been working at Airbnb, defining the design system there. So, like Andre mentioned, that today I want to talk about maybe about a little bit the future, what we can see in design when we actually use systems. But before we get there, since I think each company has a little bit different way of building their system, so you've probably seen it today, as well as defining it. So I think first we need to talk about a little bit what we have done so far and where have we gone with this work. So starting with defining our design language system, we just call it DLS. We didn't come up with a nice name for it. Naming is the hardest thing in any project, so we just went with the most basic one, which is the DLS. And I think I don't really have to tell you this. I think you have heard this many times today, that we know that design systems are now very needed. There's, I think, multiple reasons for this. Some of the reasons, I believe, are outlined here. I think we are now in a much more different, complex world than we were before. So for example, when the iPhone came out, the apps we would do would be much different. They would be simpler. They would be focused on a singular task often. But today, we actually have billion-dollar companies which their whole product is an app, which then obviously allows more kind of complexity and different kinds of flows and different kinds of ways to use the app. So we are now in a world that apps are much more complex, and I don't think it will ever go back to being simpler. I think things will become more and more complex. What we also see is that while things get harder and more complex, we also want to work faster. So before, a lot of the companies would spend years or months on features or new products. But today, a lot of the tech companies like ourselves, we develop new features every week, every few weeks, or months. So the cycles are much faster, and we make new designs and code every day. So the third thing is that I believe that our users' expectations have also risen, that the whole market has matured, that users expect more from our apps. They expect them to be well designed. They expect them to be polished. They expect them to work well and solve their problems. So people don't have this people want better apps. And I think often happens with the companies that we want to do all these things. We want things, more complex things. We want them faster, and we want to make them better. What happens is that you need more people to do that. A single person cannot no longer develop huge products or the products of today. So the scale of the teams themselves often create a new problem for companies. And that's what's kind of what's happening with Airbnb too. So Airbnb started 10 years ago with the website, and then few years into the company, they actually built their own native apps, and then later on they built tablet apps. So we had this a history of different apps being built at different times, a little bit with different ideas. So the situation started to get a little complex, where basically any designer or team would want to develop a new feature. They would have to look into these 6 different platforms or different versions of the experience we had. And the experience would be slightly different between iOS and Android. The experience obviously would be different between the native and web, and then the tablet apps would be always as well as completely different. So the situation wasn't great. We started to see these problems where the apps weren't consistent anymore. They weren't coherent for the user within the app. And then the bigger challenge started to be that the features weren't in sync anymore because it started to become harder and harder to add features. So teams started not to add features to all of the platforms, which then made it, again, more harder to add those features. So things started to diverge more and more. So the other thing was also happening at the same time that the company had a huge growth, especially in the design team. The team went from 6 people to 60 people in year and a half. And so the old methods of someone directing the design in a meeting didn't work anymore. We needed some like formalized guidance or guidelines to do the design. So we needed a design system. And I think like we probably here today have heard different ways to describe a design system. So this is our way. We like to keep it like fairly abstract. It doesn't talk about any specific implementation, but we just think it's a set of defined things that you then share within the company, that people know that those set of things exist, they can use them, and then it's actually integrated into the product itself or in the product development workflow. The difference is like, I think with a style guide, it's something like it's a guideline that you reference, you read it and you apply it. But the design system, in my mind, is more that it actually has to be part of the product and it has to be part of the whole workflow. How do you create products? And the reason, I think the goal of a lot of the design system is that one of the inspiration we had for this was this guy, Christopher Alexander, who's an architect. And he's written a few books around architecture, and one of them is Pattern Languages. The other book, This Timeless Way of Building. He talks about this problem of, like a very common problem. Like we have a group of people, we want to design something together. It's fairly hard to do that because everyone has a little bit different assumptions of the problem. They have a different idea what the solution is. And so to help this process to work together better, we need a common shared language or like a pattern language that creates a baseline for all of us. So it helps that people are on the same level or at least similar understanding of the design, what we do in the company today. And then when they make changes or new ideas, they kind of like reflect it back to that current baseline. So we set multiple principles for the design itself, for the system itself, and some goals. And there was like many goals, but these are some of the major ones, I think, which are, one is that we wanted to fix the problem of the disjointed experience with the app. So we wanted that the users who use the app, they feel that the experience feels as a cohesive whole. They feel that everything feels like an Airbnb app, and it's not. There's no like weird area that you end up going, and it's completely different. We also wanted to solve the problem of the platforms being disjointed. So we wanted to align them both in the actual experience and the design as well as the feature set. We also realized that since we are going to target a whole set of platforms, including native platforms, we cannot really design the system to be platform specific. Like we cannot really design it to be like some kind of CSS system because most native platforms don't have CSS. We can't design it that way. So we need to find a way to spec the system in an abstract way. So we started this work on obviously looking at the current design, like auditing what is the design today and what are the features today, and started noticing maybe the problems or the patterns we use. And with this project, we also actually, the company didn't like this design direction anymore. They wanted to refresh that design direction. So together with the system project, we also had a redesign project, which then ended up something like this. We went from that kind of our pink brand color everywhere to adding this green color to kind of like balance it out a little bit and like providing more white backgrounds, more kind of simple designs. And once we had this kind of idea of the direction we want to go with the design, we started thinking about the system. So we started looking at each view, each experience, and we started to see like what are the patterns we are using here. We had a team of 5 designers working on this project, and we all kind of like had a little bit different styles, but we started to see certain patterns emerge. And those were the ones that we started defining as those components. So, and with those components, we started naming them, we started reusing them in the other designs. And in our case, we set the system or the components to be fairly like large or modular instead of being very atomic. I'm going to talk about it a little bit later, but basically how we see it is that the components should be functional by itself. So when you need this kind of functionality, use the component. If the component doesn't do the functionality, create a new component. So everything is very specific or defined that this is how it works, this is how it looks. If you want something different, then it's going to be different. So we didn't want to create this like more complex web of things that things are nested. There's a lot of small pieces that you put together in different ways because we wanted to solve the consistency problem. We wanted that the experience feels cohesive. And so from this component work, we would then recognize certain like basic styles, like many other systems. We would specify the type scale, the styling for the type, as well as the color values that we use, and the spacing units that we use. And these are, whenever you create a new component, you use one of these or multiple of these units. And we call these units primitives. They are primitive values of the design, and they are not really usable by itself, but you use them to create a styling for the component. So the kind of like how we explain the system for designers in the company is that when you are working on a new project, and like you might need a similar functionality that we already have. So in this case, the other screen is the listing view, where you see the homes and you see the host. The other side of this coin is the host that sees the people who want to reserve that room. And so in a way, the context is very different, but the functionality is the same. Like what we want to do in the UI is to present a user with some additional information. So in this case, we can use the same component because the functionality and structure is the same. But that's not always the case. So sometimes we don't have all the components in the world, and we cannot necessarily predict always what the company does or where it's going. So then teams, when they need something new, they can create their own components using the primitives that we have set. And since the beginning with the design system, we always wanted that it's very connected to the engineering, that it's not only a system for designers, but it's actually it's mirrored in engineering. And the reason was that we believe that in order for this to work well, both designers and engineers have to be on the same page. And both of them need to have a motivation to use the system. Like if the designers don't use it, likely the engineers won't use it. If the engineers use it, but the designers won't, then likely it won't get used. So we need to get both of those groups of people to use it. And so what we defined is that with the same, so when the designer designs the screen, they will call out the component on the screen. They will just mark, okay, this component, this component, this component. And then the engineer can then find them from their code base with the same naming. So it doesn't matter what the platform is, they can still find the same component and build the screen. We sometimes like thought about this as a example of this, that you could technically call engineer on the phone and describe the view to them, and they could build it without seeing any designs. And I think this is the kind of like a power of a language or power of a system, that if you define things, then things get more clear. Like you don't have to specify every single thing because you have abstracted some of the details out of the process. And so, like I said, it works on the iOS this way. It also works on Android. So we have built our own frameworks, UI framework for to use, that the developers in the company use. And it also like scales to other platform sizes. We started this work with native, but we also ended up creating it in web. And initially, when we launched the system, we had maybe 40 components, and we could build a huge part of the app with that. Today, we maybe have 70 components in the core system. So it's grown, but it's still like fairly small number. And we're gonna talk about the metrics a little bit later as well. And so just kind of like a summary, I think with our system, we wanted to like keep it pretty simple. Like we wanted to keep it flat and not have this kind of like complex relationships with the different concepts. So we have a list of things. These are the primitive values that are just, here's a name, here's a value that it responds to. When you build a component, you reference those values and you build it. When you use a component, you just compose them together into some kind of view or some kind of pattern. And then this kind of idea or implementation or the spec is then implemented in different platforms. So these are all our target platforms as today. So we can also consider in the future adding additional platforms, but today these are the platforms we do. And like I said before, we didn't like really build it in specific implementation in the mind. Each of these platform implements it how that platform works, but it still follows the same rules of the system. So we didn't really talk about CSS or HTML here because like most of the platforms don't have it, and actually we don't even have it on the web today. Everything kind of like works in a similar manner, no matter what the platform is. Sometimes people ask about this timeline, or like how long does it take to create a design system? Well, it depends. But in our case, it actually didn't take that long, partly because we had a specific deadline to hit. So that's usually like a good way to speed things up if you have a specific date to hit. So we started working on this in 2016, January. And by April, we had the system and the design defined, as well as the actual product built in the different platforms. After that, about in July, we launched the system with the on web and provided the initial design and framework for it. And then I think there's been major updates to the system since then. Like usually when we have a larger product launch, there's some kind of effect it has to the system itself. So it's constantly evolving. And with web, it took a longer time to get to a certain adoption point, but like about in a year, we got into a point that the major flows in the app or in the website uses our system. And today, it's even higher than that. So where have we gone from this? Or like where are we today? So with the system, I think there's been a lot of different things we have noticed, but obviously some of the most obvious things is that we actually managed to solve this problem. Like we had the problem of coherence, having different designers design differently, but now we actually have over 100 designers. Probably most of these screens here are designed by a different designer at a different time by a different team, but they all follow similar aesthetics. And we also have managed to unify the platform. So when a designer works on a mobile product today, they basically need to design it once. So they design the whatever iOS version or an Android version, and then the system kind of translates the designs for, if needed, to another platform. But mostly our own kind of experience, like the content of the app is using our own design language. But then we do follow certain specifications of the platforms in areas like navigation, which makes sense to unify it with the platform. But we don't necessarily follow any specific design direction or guidelines from a platform perspective. So this works in Android, iOS, tablets, mobile web, desktop web. And so now if a user uses our product, no matter what the device is, there's a similar experience, and they feel that they know how to use the app. The other thing is like, I think you sometimes don't necessarily think about this, or people think like design systems, so like you create them, you set them, then they like are there forever, or like you don't change things, they're very static. But in our case, it actually hasn't been the case. The company changes a lot, like we change our designs a couple times a year, and that also means our system has to change a few times a year. But they actually, like, our systems can be a really good way to manage this change in a good way. So, for example, this is the design we had in 2016 when we started or launched the new design. And then 2017, it looked like this. We changed the styling, changed the colors, we changed the search or structure of things. We had tweaks to certain components, to the typography. And today, where we are is here, like similar things. It's still the same product using the same system, but the expressions and some of the components have changed. And you can also see this like more in a detailed way. So for example, this is the listing card we had in 2016, and then 2017 it looks like this, and 2018 it looks like this. So depends how do you look at it. It's pretty much the same. It has the same information, but the styling has changed over time. And so kind of like my point here is that like I think the design system shouldn't be static. Like it depends on your company, but our company at least, we cannot have a static system. It has to change all the time together with the evolution of the product. We also think that a system can be a way to influence design itself. So we initially created the new design direction, both for the native and web. And I think every now and then we also come up with new guidelines or patterns or styling that we start to recommend and start using the system, which then influences everyone else in the company, which then they will add their own kind of flavor to it or their own kind of ideas to it. But sometimes I think the design system shouldn't be just like you're just following and collecting what everyone else does. I think it should be also about that, like you also lead the people to a certain direction or guide them to a certain direction where the company wants to go. We also don't, because I don't know, with this evolution, we don't really do versioning. Like the DLS is always the latest version. There's no way to use the old version. And this was mainly a decision we made that we just want to kind of support this continuous change, and we don't need to think about the versions or try to make it too complicated. So the other kind of like benefit we have seen is the efficiency. Like I talked about the common language. So we have sketch files. These are symbols that the designers can use, and they can find all the components in different categories. They can then build their screens. They can define new components. And then if they're using the existing components, the engineer can find it from their code base. They can find it from the Xcode. They can find it from their Android Studio or from their like a web editor. The other thing is like we also try to think about problems that are like kind of wasteful. So one of the things is that like yes, you have a design system, you have this, you collected all these colors that the system does, but when you're actually trying to kind of keep these things up to date in multiple platforms, you end up doing a lot of work. So whenever we change a value somewhere in the system, we would actually have to get 4 engineers to change those values in different platforms. So what we have been doing now is that we want to specify the system in some kind of data format or in like very common data format, JSON, and then we would have tools or scripts that actually generates the code for that specific platform. And so when we change something, we can automatically change it in the product, and we don't have to do manual work of updating it. The other thing is like we also, like as a systems team, we also try to help the company to increase the quality or the standard that we do. And so we sometimes create tooling, sometimes it's guidelines, sometimes it's just education or workshops. But for example, some of the examples of the tooling. So if you're Airbnb employee, you can use this different UI tools. So this one is this kind of like overlay tool. So it shows you which component is which. And then if you're using the product and there's a problem, or you're just curious what this component is, you can see what it's called and like potentially who owns it. And then if you make a bug report or something, you can then address that to the right person or the right team. We also have created the tools to kind of like monitor changes, like visual regression in the system. So when someone creates a new component or changes something in the code base, if it affects any kind of visual change in a component, we actually have this automated system that tells the developer that like these things changed. Did you mean to change these things? And sometimes that's exactly what they wanted to do. Sometimes they might have accidentally also affected other things that they weren't meant to. So this helps to like avoid mistakes. So like how it looks like, it basically renders the component in a screenshot, and then it tries to see what the difference is. For example, in this case, it's very hard to see the difference. You have to really use this tool or look it closely. So the difference is that the other one has a different font size. So that's the change. But if without this tool, it might be really hard to see that this actually happened. So with the measuring part, I think it's a really hard problem, and we've been trying to really think about it. But I think it's hard to get really objective metrics of what is the success for a system like. One of the objective metrics we have found is that adoption or utilization can be that metric. So we think that the system to be successful, majority of the product should utilize it. And so how does it look like? So I said before that designers have a choice. They can either use our existing components, and we recommend them to do that when it makes sense. If it doesn't make sense or they want to test new things, you can create these new components into this team library that is basically like an experimentation area. And then if a component seems to work well, or it's generally very shared or like generic pattern, we can then add it to the main library. But this way, we don't have to block people of doing things. And so with the system, we have set up kind of like a logging for the whole product. So whenever a component gets rendered, it counts as an impression. So whenever a user uses the product, we track how many times they have seen something like certain component. And this way, we can see we can look at this data by view or overall. For example, in this listing view, we can see that 90%, the green part is using the core system, and then the 10% is team components that the teams have created. And so we can also see it in overall. So this is like something, our stats today, that on Android or generally on the native platforms, we have about 60% of the impressions come to the core components. In other ways, you can say this, that about those 70 core components are actually 70% of, or 60 or 70% of the product that users see. So it's pretty cool that you can have such a efficient use of the components, which means that it's likely have saved a lot of time for a lot of people this way. Yeah, so that's like where we are today and like some of the tooling and thinking we have done. But we also have solved some of the challenges we had before with unifying the design and the platforms. But then we also always think about like where should we go next? Like there's obviously a lot of tweaks we can do, but like what could be the next level of this? So I think the main kind of argument, or like my understanding of this, comes to the fact that a design system is basically creating a platform for design. It's kind of like an API that once you can structure and define design into some kind of structure or some kind of system, then you can build things upon that, or you can have things use that system, or other kinds of things. So before, this wasn't possible because if you just have a flat screenshot or mock-up, from a design file, usually the mockup has like, there's some random layers. They don't really have any meaning. They're just visual layers that do something, but they don't have a structure to them. So what I think is this will enable us to do is to come up with new ways to do things and think about new ideas of like how do we do design or how we design in general. So a few areas I think which are potential, possible. So one is that the tooling, obviously. So I think today our tooling is still in the same space. It's basically have been the last maybe 20 years since Photoshop. So like you have some kind of canvas, you draw some layers on it, different rectangles usually, put some text and some colors, but it's very like this still flat or like very simple visual tool. So I think like in the future, most of these tools will start to change. We start to see more tools adding different design system capabilities. Maybe they will integrate with your design system. Maybe they will allow you to create design systems. And I think like it's already happening. So we have most of the new design tools are already doing this in some level. So Sketch is adding the libraries and symbols. We have Abstract here today to talk about their solution to this. And we also have Figma, which also have their own component system. And InVision is also creating a design system manager along with the other tools. But actually, we are also building our own tool. This is mainly because we believe that since we have a system set up in a certain way, then actually building tools around it, it makes it a little bit, we can do more that way. I think it's hard for companies, like today we don't have a standard way to define a design system, so I think it can be hard for companies to address all the needs we have. So one way to do it is to actually build us our own tool. So this tool is called Lona, and it's basically a way to describe or spec design system or components in it, which then allows us to actually generate the front-end code from it. So you wouldn't actually have to build things. So how this looks like, it's a graphical tool that allows you to, it integrates with the DLS, so it has all the values and the right settings there. You can then create components. You can specify, here's some text, here's some picture area, this is the spacing, this is how the layout works. And then you can run different test cases for it. So you can say, I want to see this component in like all these 10 different sizes or devices. Or you want to say that I want to see this design in 10 different languages and see how it works in different languages, or just like with a different content. So this kind of, because we are creating this more like a structured way for a design, it also allows more ways that we can help the designer to design quality products. And the other goal is that once we have this more structured definition of the component, we can then kind of translate it to actual code, and we can that way save some of the engineering time that goes into building these components. So how the workflow works generally is that the Lona kind of pulls in the DLS we have today, and then you can then start using it or create new things. And when you're happy with it, you can then export it to different platforms. So you can export it to Sketch, or you can export it to different code platforms. And then once it's actually built or kind of ready, we can then pull it back to the system and then kind of like start this loop again. So in this way, we can like kind of bring the engineering and design even more closer together. The other ideas I think around the tools, like I already mentioned kind of like about this, like how do we augment the designer? So how can we as designers get more tools that we can use? Like I said, like today our tools are still pretty, in some ways they're stupid. Like they don't really help us necessarily design much. They just allow us to draw things, but they don't actually help us to understand or test the designs we have. And so one kind of like crazy idea or like more interesting idea we had was that we could actually, because the system creates this layer of definitions and specifications, that we could actually then use that and build a tool that can actually generate code, not from sketch or design, but from drawings. So the design system team, like that tools team, they had this theory that we have now seen apps that can classify handwritten Chinese text, which is, there's over 10,000 or 20,000 characters, and people have different ways drawing them. But today we can do it, so we should be able to build this for our design system pretty easily. So that's what the team did. So they asked different people to actually draw the components in our system, and then they would feed it to the machine learning algorithm, and then it would learn the shape of the components, and then they could run this app that basically just gets a picture or a feed from a webcam, and then in real time it can start finding the components from the system and creating the code or creating the view in actual code. So the idea here is that, like, imagine you are in a meeting, you have this discussion about this flow or something, and you just want to like draw it on a whiteboard. And now you could take a picture of that whiteboard, and then it would build to you the mock-up of that wireframe on your device. And you could test it in a meeting, like, does this make sense or does it not? And so like, you could also see this that, like, yes, this works for drawings, but this could also work in your design tool. Like, you are now creating some kind of experience, or you need a photo here, or like you need a certain kind of component, but you're not sure which one you should use. So you could ask the computer, like, what do you recommend? Like, what are the options? And then it could provide you the options that you might be interested in. One more time. Okay. So the other topic, I think it's a little out there. Like, we haven't like fully kind of worked out this idea or tested it, but I think there is a way that we can actually move as designers a little bit beyond the drawing of boxes on a canvas. And people maybe call this different things. Maybe it's like a parametric design, or it's a computational design, or it's or something else. But one way to describe this, actually Wikipedia describes it this way. So parametric design is just a way so instead of defining this is the visual result I want, you define the rules that lead to that visual result. And this is actually common practice in some industries, in architecture, or in generally when you make physical things. The CAD programs, computer-assisted design programs, they help you to actually generate the forms that you need, so you don't have to draw the 3D model by hand, but it actually helps you to generate that model based on some rules. So what if we could do this for UI design as well? So let's look at the kind of like the contrast here. So I think in the past, our design method was when the iPhone came out, we would design this like pixel-perfect mock-ups. We would have these nice textures, and like every pixel would align to some way. And that was great. That led us with really interesting and really nice designs. But the problem is that, like, once you have many different device sizes, you have many different languages, it doesn't work anymore. Like, you cannot design a custom design for every single case out there. So today, where we are, like, or getting there, is that we actually are looking for systems. Can they help us? Can they actually help us to create the scalable design that can work in all cases? But then actually, I think there's something beyond this. There's something that we could actually, yes, we still need the system, but then we could also change our workflow. So instead of like going to the component library, picking the components and like compiling them together, we could actually just say what we want. We could tell the computer, like, I need this, can you tell me how it's done? And that could lead us to think about even more scalable designs. So let's look at the example. So this is again, for contrast, this is the today's method. Like you open your design program, it has this untitled file, artboard, it's empty. You start drawing something, you put some boxes there, some rectangles, some text, and then at some point you have this design done. Maybe you used the components, maybe you used not something else, but in any case you will have this like specific visual design done based on the drawing of the boxes and lines. So what if we could just think about like what is the problem we're trying to solve and describe it in a different way? So let's take an example. I don't know how many of you have designed a terms of service update screen, maybe some of you, but it's probably the most boring design problem there is. And also because there's certain legalities that like you actually cannot innovate on it. You have to put the specific words in there. They have to be in a specific format. So it's not very like interesting problem to begin with. So we're kind of like using the designer's time for this. Maybe it doesn't make sense. But how we could do this differently instead of like trying to compose this design with some kind of visual things, we could compose the design with certain rules. So we could just basically describe what we want. So we want that the user is presented with this view, and the present could mean that this is the transition it happens, like this is the view that it opens. Then we just say that we have this content, please display it in the best way you can. So we have a long form of content, we want to put that in some kind of text row, and then we have the title, and in generally our system we use this like big titles of marquees, but in your system it might look different. And then we just say that like the user has to see this content and then they can take actions. So then we just say like user has to be able to take 2 actions. And so what the computer can then do is that they can just try to find the right components. So they can find that, well, we have this one toolbar that supports 2 actions, so let's use that. And this way, what the difference is here is that you are describing the meaning or the logic behind the screen, but you're not describing how it should be presented. And why it's that important is that we could kind of like, it's not tied to the current state of world, but it's more, the purpose of the screen usually doesn't change, but the visuals can change. So instead of specifying exactly how the screen should look like, we just specify like how it should work. And this way, when the system changes or the product changes, it can automatically change. But then there's actually more interesting factor to this, which is that it actually could be personalized for that context or user. So instead of doing a design for everyone, we could actually design for, or doing one design for everyone, we could actually do more personalized design based on the user's preferences. So like today, we often in a companies, we design something, we design it for the average user, we use our own skills and intuition to get to that to point, but then we also use user research. We ask a few people, like, how do you like this? And then we run experiments that tell us, like, this conversion increased 1%, and then we are like, yay, that's great. But then it's all of this, like, we are matching some kind of average need. It's not like, the reality is not like every user got a 1% increase in their experience. It can mean that some users got a minus 10% decrease in their experience because they don't know how to use it anymore. And some users got like maybe plus 11% difference in the design. So what we could do here is that, like, let's take another example where it's a little more complex. So we just we want to ask user to rate their experience. So what we can do, we specify those rules again, but then instead of saying that we just have this one like end goal, we actually say that if we have certain rules in place that users can have different design in this case, we can then do multiple designs. We can say that this user generally prefers patterns that are more efficient. They want to do everything at once. Some users want it to be more spaced out and like feel moving faster that way. So this is like often like a question we designers ask, like which way should we go? But then potentially, maybe there you could go both ways. And then it's not only customizing for the specific user, but you could potentially customize for different platforms. So the same description of the interface could then take different forms based on the user, based on the platform, or based on some kind of other context. So the future could look like that actually we do more personalized design that can adapt to the user's needs. It can adapt to the cultural language or the kind of way of doing things. It can also adapt to the platform. So instead of like telling everyone this is the way you should use things, we can actually let them find their own way of doing things or using things. So that's some of the ideas of the future. Just to cap it off with some takeaways, I think. I think what we today been seeing here is that design systems are like coming industry standard. I think most large tech companies now have a design system. I know a lot of companies here in Finland have a design system or are making one. So I think like it's definitely something that I think in a couple of years is going to be just the standard way of doing things because it is helpful. And then, but I would kind of like contrast with that with another point. I think that like you've seen a lot of presentations today, and they're probably like in some ways different, and that's okay. Like I think each of your company is unique, and it's not just because the product needs are different. It's also that the environment and the people and how you make decisions, how the processes work, how fast you move, what kind of needs you have, are the kind of things that you need to take in account when you design the system. I think the design system shouldn't be only just like a response to some kind of needs or problems. I think it should be also something that excites people, it pushes them forward, and I think it can also be that kind of like a way to change your company. So like if something doesn't work well, if you build it into the system to match that problem, it can lead the change to something else. Also, I think like the future, I think, is interesting that once we have this more specified platform, we can have more tools to use it, we can have more tools around design, as well as we can maybe, at least in some cases, start to think about how do we design in general, like can we move past of those sketch drawings or other rectangles on a canvas, but we could actually think about how we use patterns and how we specify things. So let's use systems. Thank you.